Hello everyone, today we're going to be working on fundamental problem 6.6, and this problem is asking us to identify the zero force members in the truss. So the first thing that I'm going to do first is we don't have to solve for the values, but simply just find out how many reactions there are based on the supports that we have. So here at point A, we could see that we have a roller, meaning we're going to have one reaction that's vertical to the support. So I'm just going to draw it going towards the roller. Mm. And then from there at our point E, we have a pin support, meaning we're going to be having two reactions. We're going to have that horizontal and vertical one. So this is simply just to know how many reactions there are because we do need to know that to be able to identify any zero force members. So from there, I'm just going to be going joint by joint and seeing which of these joints um, fall under the two cases that could give us zero force members. So if I were to start off with joint A, I'm going to simply draw it out just so you guys could visualize it a bit more, but you guys could also just like look at the image that they give us. So joint A, if we were to draw joint A, we'd have we would have our joint A. From it, we would have our reaction. It doesn't really matter um, the direction of it. We just do know that there is that reaction. And then from there, we would have our member AB. I'm going to assume that with intention. And then from there, we would have our member AE. So these are all the forces and reactions that are found at joint A. So from this, we're going to look at it and see if it could fall in any of those special cases that give us zero force members. And as you guys could see, this joint falls underneath the case 2, which is sometimes referred to the windshield wiper case, because there are three members at this joint. 1, 2, 3. Remember, to satisfy case 2, it has to be three members, no more, no less. So we have three members that meet at a joint. Two of them are collinear, which would be our reaction and our member AB. And then two of them are collinear and no external force or support reactions exist at the joint. And then that means that the non-collinear bar or member has a force of 0. So we know that our member AE has a 0 force. So we're simply going to go here and just put that this one is a 0 force. From there, I'm going to proceed to go to joint C. If we were to draw out joint C, we would just have our joint C. From there, we have our member AD. And then from there, we would also have our member BC. And this is our joint C. So now looking at this joint, we could see that this joint falls underneath case 1. And case 1 is when only two members meet at a joint at an angle other than 180 degrees, and no other external force or support reactions exist at the joint. So as you guys could see, we have these two members that meet at a joint. There is no more than two. They are not at 180 degrees, and there is no other support reaction. So that means that because it satisfies all of these criterias, that both bars have a force of 0. So we know that both of these have a 0 force. So here we found another 0 force and another 0 force. Now from there, there's still one more, joint where there's a case. Joint D. If we were to draw out joint D, from joint D, we have this force of 3 kilonewtons coming down our member BD and our member DE. So looking at this, once again, as you guys could see, we have three forces meeting at a joint, right? One, two, three. From there, we have two linear forces, the 3 kilonewtons and then the member BD. And then from there, we have one non-collinear force, which is the member DE, meaning that the member DE would have a force of 0 because it satisfies case 2. So another one. And then from there, if we were to draw out joint E, we could see that at joint E we have 1, 2, 3, 4, 4 reactions or 4 forces. And if you guys remember, both cases either require either 2 forces or 3 forces, so no more. But and then as you can see, this one has 1, 2, 3, so that doesn't fall under any of the criterias. And then joint B, we would have again 1, 2, 3. But remember, case 3, which is the only one that allows 3 forces, or yeah, a total of 3 forces. 2 of them have to be linear, and as you could see, member AB and member BD are not collinear to make member BE a 0 force. So these ones will have a force greater than 0. And then for joint E, since it would technically just be 1, 2, 3 forces once again, because we know that these two are already 0 force members. But once again, we need 2 collinear ones and 1 non-collinear, and we don't have that. So once again, joint E for member EB would have a force. So we were able to determine 4 0 force members. So I'm just going to write them up here. We have force of the member AE equaling 0 because of case 2, which is the windshield wiper case. So at joint A, because that's how we found it, at joint A, the force AE is equal to 0. Here, let me rewrite this in a different way, actually. So we have a case 2, which is the windshield wiper case, at joint A. Therefore, the force of the member AE equals 0. From there, we had that case 1, which is the one with 2 members that are simply, they can't be in that 180 degree, and there's no more than those 2 members. So case 1, we saw that at joint C, therefore making the force of the member BC equal to 0, and the force of the member CD equals 0. And then from there, we had one more case 2, at joint D. Therefore, the force of the member DE equals 0. So with that, we are done with the fundamental problem 6.6. So once again, it asked us to identify all the zero force members in the truss. I simply just went joint by joint, seeing if they met the criteria for case 1 and case 2. Thank you guys so much for watching this video. If you guys found this video useful, please feel free to give this video a thumbs up. And if you guys would like to see more videos like this, please feel free to subscribe to our channel.